Hi everyone, I'm Frames. I'm an EDA and compiler engineer at JuliaHub. So yeah, I'm here today to talk about logging in Julia, in particular about the Logging Extras package. Before I start, can you choose a more difficult and remote location for a conference? It's literally the opposite side of the world from places that are good, like Perth. Yeah, it took me a casual 42 hours to get here. It's about 170 degrees around the circle. So yeah, you could have gone like a few hundred Ks worse if you really tried. But yeah, next time I suggest like Australia, maybe New Zealand, good countries. So to talk about the Logging Extras package, so it was initially created in 2018, shortly after Julia 1.0 and the new logging standard library. Basically, I just finished my PhD, I was waiting for my visa to clear, and someone was like, I need a thing to do X. And I was like, I can make that thing, and I am very bored. Yeah, so it hasn't changed much since 2018, but we've just tagged version 1.0, so I thought it was time to like tell people about it since it's considered stable and ready to use. So the Julia 1.0 logging standard library was largely created by Claire. Thanks, Claire. It's great, and I'm basically just using the features that intended there. I also want to thank other contributors, in particular Frederick and Jacob. Yeah. So what does logging in Julia look like? It looks something like this. So we say @info or @debug or @warn, etc. Some message, which might include an interpolated string if you like. And then a list of arguments, either just by their name, or you can give them a new name in like a keyword argument kind of style. You can even just stick expressions here and it will name it according to the expression. And we can see out gets printed an info level warning. Hello, in is inserted with my interpolated value. I can see my variable with the name and the value. Similar for my named kind of keyword argument style one and for the expression. So that's logging in Julia. It's pretty similar to other logging. The use of the arguments is a bit more unique. That's not quite as common, but nothing too special, which is good. We don't want to be super weird and fancy for everything. We want saying plain easy to use. So I guess talking about logging versus printing. So we can think of printing as kind of the low-level primitive for writing to text stream. In particular, by default, it outputs to the standard out stream. In contrast, we can think of logging as a much higher level abstraction. So by default, we get this fancy styling. This is done by the console logger. It's routable, which I will talk about most of this talk, which you can use logging extras for or an otherwise customized logger. And at least if you're using the console logger, it's always printed to standard error, which is important if you're building some command line tool designed to like pipe things between each other because you don't want it to be on standard out or it'll like mess up your piping. So mostly logging should be preferred when it's the appropriate tool, which is not surprising. That's almost in the definition of appropriate tool, I guess. So who is logging for? So logging needs to serve the needs of many different users. So we can imagine an operations team who is monitoring a production environment. This is the kind of thing I did when on call at Invenia. So you've got like some system, you need to make sure that system keeps on running. So you're probably using some tool that's like for indexing logs, like CloudWatch, Sumo Logic. I guess OpenTelemetry would be another tool that's kind of in this space. But logging's also for the developer. So print layer logging is kind of the classic Julia debugging technique. It works in every language. It's not slow. It's great. So you can basically replace all of your print line statements, all of your show statements with @info instead. And finally, logging is useful for communicating with the end user on like a local interactive session. So what is log plumbing or log routing? So this diagram I use a lot to kind of explain the concept. We can imagine all of our log messages come into the system. They go into like a T logger, which splits it out and sends some all the way over to a console logger. And they go send some others through a filter. And that goes to another T logger, which breaks it out into other different files. So we can imagine that everything gets printed to the console logger, but then we also make a separate file for all errors, all warnings, all other messages, which might go to different people to examine it later or understand what's happening in thing. So our goal here is to direct the right content to the right places. So compositional logging. So the core idea behind logging extras is what I call compositional logging. We're going to break down logging into a collection of single function building blocks which we stack together to do more complicated things. Each of the components is simple, but by combining them, we can do something complex. And then the end user would configure a logger to meet their needs by composing these parts together as I described, which might be different to their needs when doing other tasks. So to break down the parts of an abstract logger, if you want to implement abstract logger, there are 4 methods you have to implement. So the first is handle message. It takes some logger, takes some arguments. It logs the thing. So this is where if you're a file logger, you'd write to file. It's used by what I call syncs, which I'll get into later, as well as by several other components of the system. The other primary method is should log. This decides if we're going to log it or not. So when I showed those positional and keyword arguments at the start, some of those are expressions. Some of those expressions could be quite expensive to compute. You could be, say, computing the condition number of a matrix, which you might want to stick in your logs because then you can be like, oh, that's why my thing isn't converging. So if the log message is disabled, you don't want to actually spend the time evaluating them. So should log decides whether or not we're going to log it before actually doing the work to produce those arguments. And that's used by the airly filtered logger, which I will talk about shortly. The other 2 parts I feel like a bit more minor. There's the min enabled level, which is an even area filter that just filters on the level of the logger with no other information. We have a min level logger for that, and catch exceptions. So catch exceptions isn't really related to the logger, but right now it is part of the logger interface. It's related to the global need of the end user. So if during the preparation of your log message you get an exception thrown, say you'd put in an expression that was wrong or maybe there's a bug in the logger itself, should Julia capture that exception? Probably good if you're running in production. We don't want the logging system to itself crash our application. Or should it not? Which is probably good when you develop it. We don't want to not catch the fact we screwed up our log messages. Yeah. So for these different functions, we have different information available to them. So as I mentioned, we have the level, which is available to everything, including the min level logger. So that's the @info, warn, etc., things like that, which is both a category as named. It's also a severity integer. So when you come to filters, you can do something like filter all things of warn or above, or you could say filter all things of 2000 or above. Then available to the should log method and thus the airly filter logger, we have the group, which is a user extended way of categorizing messages. So you might want to put things into a group being like pager group, where if one of these things is logged, someone on call gets a pager and needs to go and fix something. We've got an ID, which is a unique number for every instance of the log thing, which you can use to detect if you're getting the same message thrown in a loop and maybe you want to stop printing those, as well as the module. Then finally, we have the handle message, which can see everything. So it can also see the file where the logging function was called, as well as the line, the actual message, and all of the keyword arguments that you passed in. So logging extras exposes 3 filters. The min level logger, which allows you can set this and just disable, say, everything that isn't an error or everything that isn't a warning. The airly filtered logger, which, as I mentioned, stop messages before we have to go and compute their arguments. Or the active filter logger, which has all the control because it's actually intercepting the handle message rather than the should log. But it's already too late to avoid computing any methods. But you have full control, which is good. So we can imagine that I'm using some package, and that package gives a warning, but I know that warning doesn't apply to me for some reason. Then I don't want the end user to get spammed by this message that I already know is not actually a problem. So to do that, I might wrap the current logger with a airly filtered logger that filters on the module. So with logger sets the logger for a block of code. And then we give it an early filtered logger, which it takes a function, and that function gives you access to all of the things that is known that I showed before. And we'll say, is the module not the foo module? Say foo is the one that has the thing. And then we'll ask it to have the current logger so that that's the logger we wrap. And if we do that, call the method that's giving us the problem, we can mute the method down and it's all nice and quiet. Or if we're a bit more worried about muting something we shouldn't, we might want to use an active filter logger that we can actually check the message. So with the active filter logger, to do the same thing, we can pass in a function to filter on that's like contains message some regular expression. And then we can know that unless they change log message beyond our regular expression, we're only going to filter out the thing that we want to. And it's used exactly the same as the early filtered logger. Then we have the level override logger. So the level override logger is the opposite of min level logger. So by default, Julia has min level set to info. It never shows you debug logs, but maybe you'd like to show debug logs for some bit. So LoggingExtras.with level is a helper that just uses the level override logger in order to override the level setting. So you can do that, and we can see that here it actually does print the debug logs just inside this block, which can be useful. So then we have the transformer. So the transformer it takes the log message and it transforms it to be a different log message. So it's pretty useful because, well, you can use it to transform the log message, which you can do things like I can add some global state to all of my messages. So I might want to stick a timestamp on every single log message because I want to know when they came out. I might want to set some configuration details so that if the operations person wants to know which of our systems is throwing this, every single log message might have the system name in it, which is good for debugging things fast, even if it is rather redundant. We might want to truncate over long messages if it's just something spamming you with messages too long, but you don't want to completely discard them. It's a bit hacky, I guess, because you are losing information, which is a bit of a worry. The other neat thing we might do is add context data from the logging declaration site. So we can imagine that my system was maybe looping over a number of models. I could say with logger and then use a transform logger that will insert the model name into every log message that's passed inside this loop. And then I could go to the next model and it would be different. So that's a transformer logger. So one particularly useful use case of this is we can use it to add a stack trace to everything. So the way we go about doing that is we declare a transformer logger that takes a function as its first argument, here written with a do block. We'd pull out the stack trace with the stack trace function. For brevity, I just happen to know that the first 4 frames are the logging system. Probably you'd want to do something a little bit cleaner than this, but we just keep the frames from number 5 till the end, and then we can do some pretty printing on them, and then we're just going to add those to the keyword arguments and merge that all into the log message so that we return the message with the extra info added. And you can see printed out here. It's not the nicest pre-printing, I guess, but we can now see this method called quux, then bar, then foo, which is the one we called, and then we can see all the normal stuff that appears at the bottom of your stack trace. So that's pretty handy. Knowing exactly where your log message is coming from is useful for like debugging why this thing is happening. So the T-logger I mentioned right at the start. So this sends the same content to multiple loggers. So we can use it together with filters to apply a different transform to some of our inputs, but not to the others. Or we could use it to send a copy of our log messages to files or split the log messages up, maybe filter a group on data science, and then we have a list of data science problems that we've seen in production to give to our data science team, something like that. Yeah, that's what the T-logger is. It just splits things up and creates duplicates. I will mention there's no join logger, which will hopefully become apparent why. We just don't need one. So yeah, if we wanted to use the T-logger together with the transform logger 4, we can imagine doing something like this. In come all of our messages, goes into a T-logger, spits out 2 streams. One, which filters on this is dep1, which is defined as checking if the group is dep1, which then goes to a transform logger to add a stack trace, and then to our current logger. and the other one which filters on the other one, which just goes straight to the current logger without adding the transform logger. So this is the notion of compositionality. Rather than defining one logger to do all these things, we're just going to define these each in turn, and we can plug the blocks together to do whatever we need. So this is pretty useful. Like, I always want the stack trace when I'm getting a deprecation error, because otherwise I can't tell where it's coming from. Yeah, so it looks like this. T-logger with an early filtered logger, filter on dep1, and then calling the stack trace logger we defined on the previous slide. Otherwise, yeah, early filtered logger, not is dep1, just going straight to the current logger. So you can see that we didn't need a join because we just used the current logger twice, which happened before we overrid the logger by setting the go log argument. So the final kind of thing I want to talk about is syncs. So the sync is where the log message ends up. So conceptually, we have the idea of a pure sync. All it does is handle should message. It just always says true for should log. It always says below min level when you ask what min enabled level is. It's pure. It just does the handling of the message. Because we want to use compositionality to do all the other filtering. Basically, all of the syncs in the wild, give or take a few, are impure, but that's completely fine because we just set them to have very accepting settings, and it still works fine. I guess it's worth thinking a little bit about the transform logger versus syncs. So the transform logger semantically changes the content of the log message, whereas the sync is ultimately responsible for how to present it to the user. So we can imagine things like writing to file versus add as some colors versus encoding in JSON. You technically can do all that in the transform logger by just transforming the log message, but it's not really the use as intended. So there are 3 syncs basically in the standard library for logging. There's the console logger, which we all know and love, which has all the fancy features, nice pretty coloring. There's the null logger, which it just eats everything, gives nothing in return. It's a black hole. So when you want to turn off log messages entirely, you just say with logger, null logger, and it's all gone. Everything's gone. Finally, there's the simple logger. It's nowhere near as pretty as the console logger, but it is very simple. All right, Claire says not to use simple logger, and I kind of agree. There's no particular reason to use simple logger over console logger. It's just better. And simple logger still does some formatting, so it's not like you're getting something particularly pure. But yeah. Then we have some syncs in LoggingExtras. So LoggingExtras is not really about syncs, but we've accumulated a few over time because people are like, I want to put this somewhere. And they're like, this is somewhere. They're not bad. So the file logger just wraps simple logger, and it just takes a file name. And the only thing it does special is forces immediate flushing after every message, just in case your whole system crashes. I don't particularly see a reason to use this because it's very short, but people seem to really like it. People don't like writing open to open a file stream, but you can just open a file stream and give that to console logger instead. We have the format logger, which takes a function to control how to render messages, which is useful if you want to change the formatting of the logger a little bit. There's also a mini loggers.jl package, which has a broadly speaking similar idea, which is kind of cool. And we have the datetime rotating file logger, which is a log that periodically rolls over to be in a new file, which is useful if you've got a very long-running process that you need to kind of keep track of. There's also the logrollers.jl package, which accomplishes something fairly similar. Finally, here's some other syncs. There are like a fair few of these, which is pretty cool. There's the TensorBoard logger, which is a project I'm also involved in. It's kind of a competitor to TensorBoard X in Python. The idea is TensorFlow, but TensorBoard, very nice. So we can think of TensorBoard as being a logger which can accept numbers, which it can plot, or like vectors, which you can display as a histogram, or it can even accept sounds and all kinds of other things, like images to display. It's very rich, and the TensorBoard logger in Julia supports, I think, most of it. It's pretty cool. There's the terminal loggers, which is kind of an attempt to make something that's very similar to the console logger, but even richer. So it supports Markdown, it supports progress logging. It's nice. And then stdlib is a sync that uses the Unix syslog, which is where people expect logs to end up sometimes when they expect that. Yeah, so I showed a couple of examples there. There is a lot of examples in the logging extras README. I have stuff for truncating long messages, throttling messages based on time. Is that a good idea? I don't know, but you can do it. Adding timestamps to every log messages. There's a pile there. There's also a pile more on the Julia logging website, which Frederick made. Very good website, very useful. You should, configure your loggers. So onto future work for logging extras and logging standard library. I have a lot of things here, but I'm not going to cover all of them because they're not that important. So one question I have that I would like to get opinions on is we have all these examples in the documentation of logging extras, and they just kind of live there. They could be in a package. Putting in a package would be kind of useful because they're useful. In particular, we let us write tests, which is nice. On the other hand, they're very configurable, and someone might want to do something that's similar but not quite the same. And configuring things that are that configurable is kind of annoying, unclear, like I have to expose all these options that maybe it's better just let people write the code to do the thing. But yeah, so that is something I'm considering and would happily take people's opinions of later. Other things, we have no solution for deprecation warnings in Julia. It's an actual problem. So in Julia 1.5, we made deprecation silent by default. This is because they're adding too much performance overhead. They added 10 microseconds, which doesn't sound like a lot, but then it turned out that there was some deprecation from data structure.jl that was being used in like the most core inner loop of jump. And yeah, that's really bad because it calls that thing like a billion times and it made jump unusable. The other problem with having them was the deprecation warnings often came from dependencies of dependencies. So it wasn't a mistake that I had made by using a deprecated method. It was some other package that I depended on had made a mistake by using the deprecated method. So often for the end user, or someone relatively close to the end user, they don't want to have to go and fork some package they've never even heard of to fix these things. So we shouldn't really be displaying these things unless it was like my fault that it's wrong. But how do we do that? So the first idea would be to look at the stack trace, and then we can't check the top of the stack trace or the module field because that's where the dep ROM was declared. So that's no good. We need to go down a level or so on the stack trace to find where it was called from. I have code for this in an issue somewhere. But this has a huge problem. Calling stack trace takes 40 milliseconds, which is like definitely a long time. So we can't use that inside a filter. Even if we're like caching it, we still really don't want to use that. Maybe there's something smart we can do. The best alternative I've come up with so far is we only throw a deprecation warning if the module of the deprecation is something that you do depend on directly. This only takes 10 nanoseconds to check. However, it has false positives. I depend on this thing, but it could be that my dependency also depends on this thing, and I didn't call the deprecated method, but my dependency did. Maybe we're willing to accept some false positives in order to not silence all deprecation warnings. After all, up until 1.5, we accepted all of the false positives. So this could be like a good compromise to allow us to bring back deprecation warnings on by default that aren't completely gone. Or maybe someone has some brilliant idea that I haven't thought of that will let us have deprecation warnings back at no cost. Yeah, please come talk to me if you do. We can work on it tomorrow. Other things, so group is a single value. So I mentioned before, we might want to use group to send something to the data science team. We might want to use group to decide if we should send a pager alert. But we might want to use group to say, actually, yes, send it to the data science team, but also send a pager alert. Because group is just a single value, and a lot of the code expects group to be a single value, we can't do that because that's two values, too many values. Furthermore, LoggingExtras has verbosity macros that I haven't talked about today, but they store the verbosity in the group because the group is one of the only things available to the early filtered logger. So you can't use group at all if you're using verbosity macros. The group has already been set to how verbose to be. So it's a problem that we only have one group, and we should think about how to change that without breaking everything. Other things, there's no distinction between data and metadata. So often we want to talk to the logging system itself at the call site. We want to pass some metadata about what should be logged to the call site. So this has emergently been done by setting keys. So the console logger takes a max log keyword to control how many times a message should be logged. And then it filters that out before it prints anything. But if you use any other logger that doesn't have the max log keyword special case, doesn't special case filter it out, it'll just print that in all your logs, even though it's metadata. There has been a discussion that maybe anything prefixed with an underscore should be considered metadata and never printed, or maybe we can use a type for that. Nothing has been decided that I've seen, and that seems bad. I think my last point, we have no tables.jl logging sync. We should definitely have a tables.jl logging sync, which would be something like if I have lots of values and I'm logging out some, like, imagine I'm Optum, for example, and I'm logging out, this is the current gradient, next iteration, this is the new gradient, this is how much it's changed between the two steps. It'd be great to stick those in a logger that's backed by the tables.jl interface, and then we can call csv.jl or arrow.jl to dump that into a file, or if you want to print it, we can use pre-tables.jl. Everything can be nice and lovely. It'd be kind of a natural companion to TensorBoard logger, which does the same kind of thing, but visually. I might work on this tomorrow, or maybe someone else wants to work on it, and I would be happy to help someone work on this tomorrow. Yeah. So to wrap things up, logging in Julia is pretty powerful, it's pretty configurable. You should use LoggingExtras to configure the log plumbing for your system to meet your needs. Logging in Julia could be better. Maybe you want to work on that. If that's interesting to you, that would be cool. Yeah, that's all I have. I believe I have time for questions now.
Thank you, Frames. We have about 3 minutes for questions. Anyone out there?
Ian's going to point out something I've done wrong.
Great talk, thanks. I was just wondering, would the ecosystem benefit from the logging standard library being an upgradable standard library?
Yes, it would. Claire says it would, and I'm inclined to agree with Claire. In particular, we've had the discussion that maybe we should just stick LoggingExtras straight into that standard library.
Right.
Yeah, terminal loggers probably wouldn't exist if we could have upgraded the console logger more easily.
While I'm walking to Nathan, I'll repose my question. I think logging during pre-compilation could be improved, and the reason I'm thinking about this more is because I'm using precompiled tools to precompile more code, which has more chances to break. How do you think we could maybe do something to log errors during pre-compilation in a way that would be accessible to the user and not completely?
We could do something like that. We could do some abstract interpretation to go and find out where all the log calls are, and then remember that so we didn't have to compute that at runtime.
One quick follow-up. Do you think we should integrate that into precompiled tools, or would that be better as a separate logging library?
I'd be inclined to just always do it. If it worked, I'd be inclined to just always do it anytime a deprecation warning occurred. It's very complicated. I don't know how reliable it'd be in the presence of dynamic dispatch. That's one to ask Shuhei about, I guess. Yeah.
So I was wondering what happens with logging and distributed. So if a worker kind of logs a message, is there any way to control how that gets plumbed in with all the other logs?
I don't really know. Claire?
Sorry, I'll just come up here since I seem to be answering questions about logging. Yeah, so probably blame me because I think Simon Byrne did a bunch of work on this. For distributed, we should probably forward the logs, but we may want to do filtering on the nodes so that we don't overwhelm the master. I think Simon did a bunch of work, and then I failed to review it. So, yeah, I don't know. That's I think the answer.
Okay.
I mean, does that make sense? Do you think that's what we want to end up having, the logging coming back to the master?
Do we
Yeah.
send standard out back to the master?
Do we send a standard out back to the master? I don't know the answer.
I think we do.
Yeah. The other option is, I mean, if you're doing a high volume of logging from nodes, you may want to write that directly somewhere because otherwise you'll overwhelm the master process. So yeah, there's a few different options for that. I think we should have a standard way to send it back to the master process though.
Okay, thank you.